welcome back to my YouTube channel. So today we are going to solve day 23 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today we are going to solve problem number 2641, cousins in binary tree 2. Okay, so we have given the root of a binary tree. We have to replace the value of each node in the tree with the sum of all its cousin values. Okay, two nodes of a binary tree are cousins if they have the same depth with different parents. Okay, we have to return the root of the modified tree, and note that the depth of a node is the number of edges in the path from the root node to it. Okay, so now let's understand this with an example here. So this is a tree given to us, right? 5 4 9 1 10 null 7. Okay, this is nothing but null. Okay, so now this is a modified tree that we have to return. Okay, so now how we are going to return that? Okay, so initially you see that this node with value 5 doesn't have any cousins, right? So we are going to take its sum as 0. Okay, so this is done. Then node with value 4 doesn't have any cousins. Okay, because both are having same parent, right? This 4 and 9, and this node 4 doesn't have any cousins. Okay, so here also I'm writing 0. This node with value 9 doesn't have any cousins, right? So its sum is also 0. Okay, now see this node with value 1. Okay, so this 1 has this parent 4. Okay, and this 10 has also this parent, but this 7 has this parent 9. Okay, so these two are brothers, right? These 4 and 9, let's say these two are the brothers. Okay, this 4 has this children 1. Okay, so definitely this 1 and 7 are cousin, right? So node with the value 1 has a cousin with value 7, right? So its sum is 7. Okay, so here I'm just going to replace this one with 7. Okay, now see this 10. Okay, so this 10 cousin is just 7, right? This 10 and 1 both are actually brother and sister because both have same parent, right? But this 9 and 4 are brothers, so this 10 and 7 are cousins. Okay, so here I'm just going to replace this 10 with 7. Okay, so this is done. Now see this 7. So this 7 has this parent 9. Okay, 7 has parent 9, and 10 and 1 has parent 4, right? 10 and 1 has parent 4, and you know that 4 and 9 are brothers. Okay, so definitely 7 1 and 10 are cousins, right? So here sum of these two cousins 10 and 1 is 11, so that is why I'm writing 11 here. Okay, so node with the value 7 has cousins with value 1 and 10, so its sum is 11. Okay, so this is what we need to do. Okay, so now how we are going to solve this problem? Okay, so this problem is actually same like yesterday's problem, right? So if you see the yesterday's problem, okay, I will show you that. That is day 22 problem. Okay, so this largest kth largest sum in a binary tree. Okay, so in this problem also, what we were doing just finding the level sums, right? These are different level by level. We have to find the sum, and k02 value given us, so we have to find the second largest sum. Okay, so if you see the submissions here, this is what we have submitted yesterday. Okay, so I'm just going to modify this code only, okay, for today's problem. So here let me just replace it. Okay, so this was yesterday's code. Okay, so here we were using priority queue and we were finding a level by level sum. Okay, uh, all this stuff, right? And then we have to find the second largest sum. Okay, so this is the way. Okay, so in this problem also I'm going to calculate the level by level sum. Okay, so let me just go to this problem. So in this problem also I'm going to find the level by level sum here. Okay, so let's understand how I'm going to solve this. Okay, so first let me draw this tree. So first is 5, then we have 4, then we have 9 here, then we have 1 here, here we have 10, and here we have 7. Okay, so let me just double check. 5 4 9 1 10 7. Okay, so this is our tree, right? So first thing we have to do here. Okay, so how I'm going to make a tree? So first thing is here, if you see this total sum of this level is 5. Okay, the total sum of this level is 13. Okay, and the total sum of this level is 18. right? So now here one thing, uh, let's suppose if I am at this position, okay, if I am at this position, okay, and I want to update the value for this one, okay, so how I'm going to update? So for this parent, okay, for this parent 4, for this parent 4 we have these children 1 and 10, right? And I want to update the value of this one. So can I do one thing here? Total value of this level is 18. In this 18 total value, okay, I will subtract the sum of these two, okay, because these two are the actual brother and sisters, okay, having same parent. So here 10 plus 1 is 11. So here 18 minus 1, 18 minus 11 is going to give me 7, and this 7 is accurate now. I was updating this 1 to 7 only, and this 7 is nothing but the sum of the cousins values, right? So these here we have cousins, right? So that is why we are getting 7 here, okay. So that's the same thing. That is why we have to find the level by level sums, okay. So here if I want to update this, okay, so let me use some different pen. So here if I want to update this, so how I'm going to update it? Total is 18 and minus here, uh, what is the total sum we are getting here at this particular level, okay, at this here only. Total sum here for this parent 9 is 7 only, okay. So 18 minus 7 is equal to 11, and this 11 is accurate. This 11 is the sum that we are getting here, right? So this is the way we have to do this, okay. So we have to find level by level sum, okay, just like yesterday's problem we were finding the level by level sum, okay. So we have to do this, and after doing that, for current parent we have to do the summation and subtract that, which is going to give me the cousins total sum, okay. So that's what. So how I'm going to solve this problem, okay. So here same like yesterday, we have to create a queue, okay. So let's create this one queue, and in this queue we have to add first this value, okay, 5. So here I have added this 5, okay. So now I have added this root, okay. And now after that, just set the root value to 0, because definitely our root will always have some 0 only, okay, because there is no cousin for this root, right? So this is done, okay. So now what we need to do here, I have to first poll this element, okay, remove this 5, okay. I have removed this 5. So let's say my 5 is here, okay. I pulled this from my queue, okay. Now for 5 we have these two children 4 and 9. Just add those children 4 and 9, okay. I have added these two, okay. Now calculate the total level sum, okay, of these two. So total level sum we will get as 13, okay. This is done. This is nothing but total level sum, okay, TLS, okay, total level sum. Now for each node, okay, for each these two values, we have to find the cousin sum, right? So for if you see, first just see this here 5, and in 5 we have left value is 4, okay. 4 5, the value in the left is 4, okay. So 4 5, value in the left is 4, okay. So this is one thing. Now after that, here I have to calculate the sibling sum, right? So here sibling sum, let's update that sibling sum is equal to sibling sum, let's say initially as 0 plus no dot left dot value, okay. For this 5 I'm doing that. So sibling sum initially is 0, 0 plus 4 is equal to 4, okay. And then for this particular node, okay, node dot right dot value. So sibling sum only we are calculating, right? So here sibling sum in 4, and now in this 4 I am adding this value, okay, 9. So 4 plus 9 is 13, okay. So 13 is the total sum of the siblings means both having the same parent, okay. 4 and 9 same parent, okay. So I have got the sibling sum as 13, okay. This is nothing but my sibling sum. Now here one more thing, sibling sum is 13 and my total sum, okay, total level sum is also 13. So total level sum we have, and we have sibling sum, right? So here for this total level sum minus sibling sum, total level sum is 13, and sibling sum is also 13 because both are actually brother and sister, like same parent, right? Both are siblings. So 13 minus 13, 0. So I'm going to update it to 0. Okay, same way for this one, 13 minus 13, 0. Okay, so this is what we need to do. Then we have to remove this, add the children for this 4, remove this, add the children for this one, calculate the total level sum, and after calculating the total level sum, we have to calculate the sibling sum. And then how I'm going to update the value? I'm going to update the value like this: total level sum minus sibling sum. Okay, like this every time. Okay, so now let's write the code. With code you will be able to understand, okay, what I'm saying here. So here just remove it. We are going to use simple queue like yesterday, BFS approach. Okay, that is very simple. So here in the starting, let me just zoom it. If root is equal to null, then in that case simply return null. Okay, and then we have to use a queue for BFS travel queue, and here 3 node queue is equal to new linked list. Okay, and then in the queue just add the root. Okay, and then we have to mark the root's value as 0 since it has no cousins. Okay, so root dot val, I'm going to set it to 0. Okay, now we have to start the BFS traversal. So here simple while loop, and in this I'm going to run it until my queue is not empty. Okay, all right. So inside this, first, what is the size of my queue? So initially I have just added one element, so size is 1 only. Okay, queue dot size, I got the size 1. Okay, and I have to calculate the level sum. So initially just say that my level sum is 0. Okay, so now after that we have to create a array list to store nodes at the current level. Okay, so list, here I'm just going to write 3 node current level is equal to new array list. Okay, now after that we have to calculate the total sum at this level and collect the nodes. Okay, so this loop is definitely going to run just one time. Okay, right now, because there is just single element right now, right here in my queue. Okay, so int I is equal to 0, I is less than size, and I plus plus, and after that what is my current node? Okay, so tree node is equal to q dot poll, take the current node. Okay, so for this current node, okay, so current level. Okay, so in the current level just add this node, current level dot add. Okay, I have added this node as my current level. Okay, now what we have to do? Okay, so here if the node dot left. Okay, so same here, if I go to diagram 5. Okay, for 5 node dot left, if node dot left, okay, is not equal to null, is not equal to null, then in that case we have to add this value in the queue, right? Queue dot add node dot left, we have to add this, and definitely we have to calculate the level sum, right? So here level sum is equal to level sum plus node dot left dot val. Okay, this is what we need to do. Okay, so here just copy this. So this is for left, we have to do the same thing for right. So here just update, instead of left, right. Okay, here q dot add right, and here also right. Okay, this is done. Now we have calculated the level sums. Okay, so now here this for loop ends. Okay, and now after that we have calculated the level sum. Okay, so now what next? So we have to update each node's value based on the sum of cousins, right? So for that, let's iterate for using for each loop. I'm iterating over all the nodes. Okay, and the nodes from where? Okay, the nodes which are there in my current level. So right now there is just one node, right? So here I'm just going to iterate over that. Okay, side by side I'm updating everything, right? So right now sibling sum, take it as 0. Okay, sibling sum is equal to 0. Okay, now I am going to check if here we have to check if my node dot left is not equal to null. Okay, so here I'm just going to operate the sibling sum. Okay, so total level sum we have got. Okay, now total sibling sum. Okay, sibling sum is nothing but having same parent, both having same parent, right? So here I'm just going to write node dot left is not equal to null. Then in the sibling sum I have to add that sibling sum is equal to sibling sum plus node dot left dot var. Okay, sibling sum I'm doing. I have calculated level sum here, total level sum. Okay, now sibling sum having same parent, this is one thing. Now right. Okay, so for that same parent, okay, the children the right. Okay, both are actual siblings, right? So this is done. Okay, now how to get the cousin sum? Okay, so this and this we have calculated total sibling sum. Okay, now I have to update this. So this value I have to update simply means node dot left value I want to update, right? So here I am going to write if node dot left is not equal to null, then only we have to update my node dot left dot value. Okay, so I have to update my node dot left dot value. And how I'm going to update that? So I have to update this value as total level sum minus sibling sum, right? So here I can write it like this, right? Level sum, okay, minus sibling sum. Okay, here sibling sum. Okay, this is how I'm going to update that, right? Now same way copy this, and we are actually done with this problem. That's what. Okay, so here if there is a right children, we have to update that. Okay, so if no dot right is not equal to null, then I have to update the right as well. Okay, no dot right dot value is nothing but a level sum minus sibling sum, right? This is done. And here if you see, here my while loop ends. Okay, I have processed all the elements in my queue becomes empty. Now in the end we have to just return the root. Okay, because I am updating the values side by side. Okay, so now let's run it and see if there are any code issues. So all the test cases has been accepted. Wonderful, let's submit it. So see, our solution is accepted, right? And the time complexity for this problem is going to be of n, right? Since we are iterating over all the values, okay, one by one, all the nodes, right? So here all the elements in queue we are iterating one by one, right? So overall time complexity I'm going to say is O of n. Okay, so I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.